So until now we have studied about the first shifting property, second shifting property and many more properties of Laplace transform. The first shifting property, it says that whenever the Laplace transform of f of t is given to be capital F of s, then the Laplace transform of the function multiplied by e to the power at, that is equal to capital F of s minus a. So that means whenever you multiply by e to the power at, you have to just change s with s minus a. This is what this property says. Another property, second shifting property, it says that whenever you have the Laplace transform of f of t as capital F of s, then the Laplace transform of u of t minus a multiplied by f of t minus a, that is equal to e to the power minus a as capital F of s. Where what is this u? This u is the unit step function. And this second shifting property, this is a very useful property whenever we are to take the inverse Laplace transform. So in that case, suppose some function is given to you and e to the power something is given to you. In that case, it is equivalent to this quantity u of t minus a, and whatever is the Laplace inverse of capital F of s, that is small f of t. So here in place of t we have t minus a, and whatever is minus a here, that same minus a comes here in the in place of variable t, we have t minus a. So this is what we know. And if here in place of the function f of t we had this property, that Laplace transform of u of t minus a into f of t minus a, this is equal to e to the power minus as into f of s. So according to this property, f of t, if the function is given to be equal to 1, that means here we have 1. So whatever is the Laplace transform of this function, what is the Laplace transform of 1? That is equal to 1 divided by s. So here we have this to be e to the power minus as into the Laplace transform of 1 divided by s here. And if you have if you wanted to calculate the Laplace transform of u of t, what would be that? That means a is equal to 0 and the function f of t is equal to 1 in this respective expression. So that means whenever e is equal to 0, so you have e to the power minus 0, so that is 1, and the Laplace transform, what is f of s? That is the Laplace transform of f of t, and f of t is given to be 1. So the Laplace transform of f of t, that is equal to the Laplace transform of 1, that is equal to 1 upon s. So its answer is equal to 1 by s. So these are certain results that we already know. So according to this, let us see some questions. The first question says we are to find the inverse Laplace transform of the function f of s, and it is given to be e to the power minus pi s divided by s plus 3. So here, if you see, here we have e to the power minus pi s with us. So that means we can use the second shifting property here very easily. So according to that whatever we have in product with this particular term e to the power minus pi s, so we have this function g of s is equal to 1 divided by s plus 3. So we can first calculate what is the inverse of this particular function. So it is equal to small g of t, so it would be Laplace inverse of g of s. So Laplace inverse of 1 by s plus 3, and using the first shifting property, it is equal to e to the power minus 3t. So this is the result. Now according to second shifting property, what the Laplace inverse transform of e to the power minus pi s g of s, that is equal to u to the power, here in the coefficient of s is minus pi, so we have u of t minus pi, g of t minus pi. And what was our function g of t? Our function g of t was equal to e to the power minus 3t. So here you would have to replace t with t minus pi. So that means your function g of t minus pi, it would become e to the power minus 3 t minus pi. So we'll substitute that value here. So it is equal to this. So this is the final answer. So let us now move on to the next example, which says that we are to compute the inverse Laplace transform of e to the power minus s divided by s plus 1 cube. So here also you notice that we have something multiplied to this e to the power minus s. So that means we can use second shifting property here. So for that, firstly what we will do, we will suppose the term 1 divided by s plus 1 whole cube to be g of s. So that we can compute the inverse Laplace transform of this term. So we assume that the inverse Laplace transform is g of t, and we can substitute the values. Now we can apply the first shifting property. According to that, first shifting property says the Laplace transform of f of s minus a, that is equal to e to the power a s into Laplace inverse of f of s. So this is the first shifting property in the inverse terms. So here, because we have the Laplace transform of some function of s plus 1, so we can write s plus 1 as s minus of minus 1. So that means your a here is equal to minus 1. If a is equal to minus 1, so we have e to the power minus at. So this term is e to the power minus t, and the Laplace inverse of the function, the same function where now you have replaced s minus a with s. So it is 1 divided by s cube. So now if you are to calculate Laplace inverse of 1 divided by s cube, that is equal to t square divided by 2 factorial. So now because you have the Laplace transform of 1 divided by s plus 1 cube, so the Laplace inverse transform of e to the power minus s multiplied by this function would be equal to the second shifting property u of t minus 1 multiplied by g of t minus 1. So u of t minus 1 would come as such, and because we know what is g of t, this quantity is equal to g of t. We have just calculated. So what we have to do, we have to replace t with t minus 1 here. So when you replace t with t minus 1, so it becomes e to the power minus t minus 1 into t minus 1 whole square divided by 2 factorial. So this is their final answer. So now these are very simple questions. So let us now see another question which says that calculate or evaluate the expression Laplace inverse of e to the power minus s minus 3 e to the power minus 3s divided by s square. So first of all, we can separate all these terms using the linearity property. So accordingly, we will have Laplace inverse of e to the power minus s divided by s square minus 3 Laplace inverse of e to the power minus 3s divided by s square. So that it is equal to, here we will what we will do, we will apply the second shifting property. So it would be equal to u of t minus 1 into the say the Laplace transform of this is g of t minus 1. Suppose your g of s, that is equal to 1 by s square. Therefore what would be g of t? It would be the Laplace inverse of g of s. So that means the Laplace inverse of 1 by s square. So what is this term? This is t divided by 1 factorial. So the g of t is equal to t divided by 1 factorial. So that means g of t minus 1, what is this? This is equal to t minus 1 divided by 1. So that is this. This is the Laplace transform of first quantity. And what about second? For the second, we have minus 3 Laplace inverse of e to the power minus 3s divided by s square. So again, using this second shifting property, it would be equal to u of t minus 3, because here our a is equal to minus 3. So it is t minus a. So it is t minus 3 into g of t minus 3. So that is the thing. Because this function 1 by s square, that is same as here. Okay. So we have minus 3 u of t minus 3 into g of t was t divided by 1 factorial. So g of t minus 3 would be t minus 3. So that means our final answer is u of t minus 1 into t minus 1 minus 3 u of t minus 3 into t minus 3. So this is the final answer. So next we have another question. It says that find the inverse Laplace transform of f e to the power minus s by 2 plus pi e to the power minus s divided by s square plus pi square. So in terms of unit step function. So the first step over here is we will separate out the terms. So it would be equal to Laplace inverse of the first term s divided by s square plus pi square into e to the power minus s by 2 and plus the Laplace inverse of pi divided by s square plus pi square into e to the power minus s. So this is using the linearity property. So this is using the linearity property. So using this linearity property, now we are able to apply the second shifting property here. So we can apply the second shifting property. Why? Because if you notice, we have this term e to the power something multiplied to something, and here also e to the power something into some other function of s. So that means we can apply second shifting property here. So it would be, the first term here would be u of t minus whatever is the coefficient of s here. So the coefficient of s here is minus 1 by 2 and the value of function calculated at t minus 1 by 2, where what is this function f1, where we say our f1 is equal to, where f1t, that is equal to Laplace inverse of this f1s. And what is f1s? That is equal to this whole quantity. So s divided by s square plus pi square. So the Laplace inverse of this quantity is equal to cos pi t. This is according to the direct formula of Laplace transform, inverse Laplace transform. Okay, so this is our f1t. Now look at the second term. Here also we will apply the second shifting property. So this becomes u t minus whatever is the coefficient of s here. So it is equal to minus 1, so t minus 1. And then multiplied by f2 of t minus 1. Now what is f2? f2 would be the inverse Laplace transform of this function. So that is equal to f of t, that is equal to Laplace inverse of f2s, which is equal to Laplace inverse of pi divided by s square plus pi square. That is what was our function? Yes, pi divided by s square plus pi square. And what is this? This is equal to sine pi t. So this is sine pi t. Okay. Now we have f1t, now we have f2t. Therefore, we have our answer, this term would become u of t minus 1 by 2. And then what is the value of f1? f1t was this quantity. What would be f1 of t minus half? So here we will replace t with t minus half. So we would have cos pi of t minus 1 by 2. So this is the first term, and the second term u of t minus 1, and here f2t was this term. So here also we will replace t with t minus 1 because we require t minus 1. So it would be sine pi t minus 1. Okay, so we have u of t minus 1 by 2. Now here you see what is this? This is cos of pi t minus pi by 2. And the second quantity would come as such. So sine of pi t minus pi. So now you have some angle minus pi by 2. So using the laws of trigonometry, suppose you are standing over here. So minus pi by 2 means you are in fourth quadrant, and in fourth quadrant your angle is negative, and because we have pi by 2 it is converted to sine. So we have sine minus sine pi t here in place of this using the laws of trigonometry, and we have u of t minus 1 as such. Now sine of pi t minus pi means you are here, you are somewhere here in third quadrant. In third quadrant also we have a negative value of sine, but sine would remain as such. So we would have sine pi t. So its final value would be equal to minus sine pi t multiplied by u of t minus half plus u of t minus 1. So this is the final answer.